I'm Mr. Precella, and today we are going to look at a major topic in algebra, something called solving inequalities using cut points. We're up to assignment number 8. We go with about one new topic a class period. So on Monday we'll be doing some graphing. That's where we start graphing. And then you see a review for the first quiz and then the first quiz. The quizzes are used for your foundations grade. You get 2 grades in this course, college algebra and foundations of algebra. Your goal is to pass college algebra. If you make an A in college algebra, you've made an A in the foundations course. Okay? So if you're looking through this and wondering, wait, now what is the purpose? Why are there quizzes and tests? The quizzes are used to calculate your foundations grade. The tests are used for college algebra. That's why we're separating 0, 3, 14 and college algebra. If your college algebra grade is higher than your foundations average, then you get that grade for the foundations. But the main thing, your purpose in this course is not to pass foundations of algebra, it's to pass college algebra, okay? And that's why we meet for, we have that 3-hour time block, which we never used, or used all of. But what will we be doing? Well, I want to make sure y'all recall this stuff we were doing at the end of class the last time. This interval notation, where you had a number line with numbers labeled on the number line, and either open or closed circles. A closed circle, or a closed dot, as my brother wrote, means that you're including that number. An open circle or open dot means you're not including it. If you were wondering which region is shaded right here that I'm showing with my pen, I think that's in blue, then you would say all the numbers between -4 and -2, including -4, but not including -2. Now, which numbers are here in this red region? Well, all the numbers between 0 and 2, including 0 and including 2. Before you decide, well, that's just 3 numbers, 0, 1, and 2, realize when I say numbers here, I mean the formal definition. So think of all those decimal numbers. 1.325 is in here, 1.326, and so forth. So there's actually a whole lot of numbers. And then any number to the right of 4, that's the region that's shaded black, including 4. To write that out in a shorthand notation, that's what you do with interval notation, and you're going to use brackets for closed circles and parentheses for the open. Also, you always put parentheses by infinity symbols, okay? Because that parentheses means not including. It wouldn't make sense to talk about all the numbers between 4 and infinity, including 4, and including infinity. That would be the same as including this arrow. That infinity only represents that arrow there. Okay? I think I gave all of you, I tried to catch everyone, maybe I didn't. I have some printouts right here. Is there anyone who didn't hand one of these to? I'll bring it to you. Who didn't get one? This is a rare, I'm blind. Here, there you go. This is one of those rare times I'm giving you a sheet of paper. In this digital era, we don't get much paper handouts anymore. But this sheet of paper are the steps that we will be using when doing today's assignment. And I just want to look at step number 5. These first 4 steps talk you through how to draw a number line, how to label these cut points on the number line. That's what you call the numbers that have an open or closed circle. And then how to decide whether there's open and closed circles and how to shade. That's steps 1, 2, 3, 4. That's the new stuff. Step 5, you have the, let's see if I can make that a little bigger. There. Step 5, you have the number line drawn. And what I'm saying there is exactly what we were doing the last time, writing the stuff in interval notation. Express the shaded intervals using interval notation. Use a square bracket for closed circles. Use parentheses for open. Always use parentheses for infinity symbols. So, with that in mind, let me see. Everyone has one of those sheets of paper. So I'm going to be referring to it. And while I'm thinking about it, I should go ahead and mention on Canvas, if you lose the sequence of steps, look under Files, and there's a file that says Math 1314 Documents Fall 22, and there it is, Cut Point Method for Solving Inequalities. Okay? Any pieces of paper you ever get will always be backed up, or there'll be someplace that you can get it, because I know it's sort of hard to keep up with a sheet of paper. Remember back in the olden days, we'd give the students the syllabus and tell them, now keep this sheet of paper all semester long, okay? But we don't have to do that anymore. It's always there on Canvas. So today's lesson is going to be, let me see. Oops. We're going to be solving inequalities using cut points. So at the end of this class, that phrase cut points, if you hear it, it's going to mean something to you, hopefully. First of all, we've solved equations this semester. An equation has an equal sign. Let's see. No. Let me find what we were doing the last time. Like right here, you remember solving these absolute value equations? An equation has an equal sign in it. Today, we're going to solve inequalities. And what the heck is an inequality? An inequality contains a less than symbol, a greater than symbol, a less than or equal to, or a greater than or equal to symbol. Theoretically, it could have a not equal to symbol, but we're not going to be solving that sort of inequality. Okay? If you want to solve an inequality that has a not equal to, just do it as if it were an equal sign. So we're going to be discussing how to solve something that has a less than or a greater than in it. I might have mentioned previously the student that spoke to me once, he was a waiter at a restaurant, and he said, I asked something about, he made the mistake, or he said, I'm taking math at Del Mar, and I was, wow, okay, and, I guess he knew I worked there, and I made the mistake of saying, so how's it going? And he was like, it's going okay, but my teacher's an idiot. I immediately want to disengage from this conversation, but he continued to explain why his teacher was an idiot. He said his teacher tells him that they got to not just learn how to do the problems, they've got to study the instructions. And he knew as a result that teacher was an idiot. No, there's no need for him to study instructions. And I was like, wait, actually, that's not a bad idea to study the instructions. And you could tell at that point that student was thinking, oh no, it's another one of them idiots. Okay? But how does this differ from the other instructions? Notice how it says solve the inequality. Another way, what makes this problem different from everything else we've done this semester? Well, there's that less than or equal to. It's sort of important that you be able to distinguish when do you do what. When you have a less than or a greater than, you're going to be following these steps for the cut point method. This cut point method will solve any type of inequality. Okay? And you know how to do each one of the little steps. So let's just jump in. I'm going to write down this first problem, and we'll start following the instructions on here. Okay? This is a recipe. I call it a recipe because if you follow it, boom, you're going to wind up with the right answer. And once we do the first example, I'll tell you the way I was taught it the first time I ever saw it in college at good old SFA. So this is just problem number 5 is a really good first example because it's going to illustrate every step. 3x over x plus 2 is less than or equal to 4. Okay? So solve the inequality. Notice at no time will the instructions say use the cut point method. You have to know, if there's a less than or greater than symbol, I follow these steps. I'm going to draw a number line and shade regions. Okay? So everyone has the steps? Everyone get them? Let's read the first step. It says, well, we say to solve a nonlinear inequality. Actually, this will solve any type of inequality. Replace the inequality symbol with an equal sign and solve for x. These numbers are called solution cut points. The cut points are the numbers that are going to be on the number line with the open and closed circles. Steps 1 and 2 tell you how to find all of the cut points. The first ones we're finding are what's called solution cut points. And I abbreviate those as SCP. So we're finding the solution cut points. Replace the less than or equal to with just an equal sign. So we have 3x over x plus 2 equals 4. I'm going to go ahead and replace that 4, or rewrite that 4 as a 4 over 1. Because what am I going to do? We had some problems last week where we had fraction equals fraction. And I said there's going to be a lot of those before this is all over. What do I do to solve an equation that's in the form fraction equals fraction? Cross multiply. I was going to give you the hint. 2 words, C and M are what they start with. Cross multiply, yeah. So let's cross multiply. I'm doing this first. So that would be 4 times x, that's a 4x. 4 times 2 is a 8 equals 3x times 1, just 3x. Now let's move the stuff around and isolate the x. Look at how the way I'm going to move my arrows. I'm not going to move the 4x over to the right because 3 minus 4 would give me a negative. I think it would work out easier if we do this. Let's subtract 3x and subtract 8. Those arrows mean move it over and change the sign. So what would we have? We'd have 4x minus 3x. Is that just going to leave me 1x or x equals, what number will I have on the right-hand side? Negative 8? Okay. That's going to be one of the numbers that we label on the number line. But every cut point on the number line has to have an open or closed circle. Well, I have a note here that tells you how to figure out if you should have an open or closed circle. I wonder if y'all can follow that step or read through that step and tell me what are we going to put there? Under where it says note, if the problem contains a less than or equal to or a greater than or equal to, use a closed circle. If the problem contains just a plain less than or greater than, use an open circle. So what are we going to put here? A closed circle. So let me make a note of that. There was an equal sign, so it's going to be a closed circle. Years ago, a student told me that the way she remembered that if there's an equal sign, it's a closed circle, and if there isn't, it's an open circle, was she asked herself, what takes up more ink? What uses more ink to write? The less than or equal to, or just a plain less than? Well, the one that has the equal sign. Which one uses more ink, a closed circle or an open circle? The closed. I thought that was a clever little way she did to remember that. Which one used more ink? Well, the ones that have the equal sign use more ink, so use a closed circle because that's what uses more ink. Okay? Not that you have to have this memorized, but anything you have here in your head that you don't have to be just reading through every time, it speeds you along. Okay? Now, we're now ready to do step 2. I'm going to draw a vertical line right there. Now, step 2 tells us how to find something called denominator cut points. They can be called either denominator or domain. In a few class meetings, we'll define something called the domain, and then you might understand why they're called that. I like denominator cut points as the name, though. But they'll be abbreviated DCP. So let's read what it says. Set any denominator set you have not equal to 0 and solve for x. These numbers are called denominator cut points. We've already found denominator cut points. We just weren't calling it that. Do I remember a week ago during that horrible long assignment over rational and radical equations? We were looking at fractions and we were saying, what number would make this denominator 0? You can never have a 0 in the bottom of a fraction. And that's what we would do. We would do this. We'd say denominator can't be 0. X can't be what? Negative 2. If x were negative 2, we would have a negative 6 on the top and negative 2 plus 2, a 0 on the bottom. You can never have a 0 on the bottom in the bottom of a fraction. Sometimes students don't believe that unless they see it on a calculator. If I had negative 6 divided by 0, it's not going to give me the answer 0. It's going to say error, division by 0. You can't have a 0 in the bottom of a fraction. Now, there's a note there telling you whether to use open or closed circles for the denominator cut points. Could y'all figure out what I'm saying there? Well, it's pretty easy, right? Always label denominator cut points with what? Open circle. Always. For the denominator cut points, it's an open circle. Remember, open circles mean not including. Closed circles mean including. You never want to include negative 2 as an answer because that's when the fraction is undefined. Let's look back at the solution cut point and let me see if I can explain to you why I have this statement here. If there's an equal sign, closed circle. If there isn't, open circle. If I were to plug negative 8 in for x right here, where's my calculator? Let's plug a negative 8 in here. 3 times negative 8, that would be a negative 24. And what would we have in the bottom? Negative 8 plus 2, what would that be? Negative 6. So negative 24 divided by negative 6 is a positive 4. 4 is less than or equal to 4. Would that be a true statement? 4 is less than or equal to 4. Yes, because of the equal sign. So we want to include it if there's an equal sign because you're getting a true statement. But if there hadn't been that equal sign there, we would have the bizarre statement 4 is less than 4. That's not true. Right? So just trying to justify why this little method works. So why do I say if there's an equal sign, put a closed circle? If there's an equal sign, then you're getting a true statement when you plug it in. Okay? Now we're up to the point where we draw our number line. So I'm drawing a number line. And I'm going to label only the cut points. The cut points are negative 8 and negative 2. Make sure you put those cut points in numerical order. What do I mean by that? Do not put negative 2 here and negative 8 there. When you have negative numbers, it can get a little tricky. Which one of these is closer to the negative infinity? Negative 8 or negative 2? Negative 8. And then negative 2. So closed circle on negative 8. Open circle on negative 2. Notice how it's starting to look like this, where you have the number line drawn with some open and closed circles. What we need to do now is shade part of the number line, and that's what step 4 is. So far, right here where I say SCP, that was step 1. You know what? Let me label it. Step 1. Right here, the DCPs, step 2. Right out here, drawing the number line, that's step 3. Step 4, we're going to figure out which region to shade. So reading step 4. Is that big enough for y'all? Select a number in each interval and substitute it into the original inequality. If the inequality is true, shade that interval. If the inequality is false, cross it out. So let's look at this. We're going to choose a number between each one of these endpoints right here. Choose any number you want between negative infinity. Oh, can y'all tell my infinities from my 8s? Seems like 8 always winds up when there's an infinity involved. But that's the pink ones are the infinity symbols. The 8 is the black ink, okay? So I need a number, any number between negative infinity and negative 8. Thinking of the number line. If this is negative 8, then there's negative 9, negative 10, negative 11, negative 12, negative 1,000,000. I think I'm going to use negative 9. Okay? It's going to be up to you to decide on which number, but you could have used the negative 10 and negative 11 and negative 12, any number between negative 8 and negative infinity. Now we need a number between negative 8 and negative 2. So you could choose negative 3, negative 4, negative 5, negative 6, negative 7. I think I'll use negative 3. And finally, we need a number between negative 2 and infinity. So think of those numbers. There's negative 2, then negative 1, 0. If I can use 0, I think that's the easiest number to use. So for this third interval, I'll choose 0. Okay. To decide whether or not you're going to shade the interval, you choose one number from each interval, and you're plugging it into the original problem right up here. Plug it into 3x over x plus 2 is less than or equal to 4. And see, are you getting a true statement or a false statement? You might want to have a calculator handy to help you. Plugging in the negative 9. 3 times negative 9, that's a negative 27. What are we going to have on the bottom? Negative 9 plus 2, negative 7, good, is less than or equal to 4. Well, it's certainly not equal to 4, but what's 27? Negative divided by negative is positive, so I'm just going to punch in 27 divided by 7, and we are getting a 3.85 or something. So what are y'all thinking? True? 3.857 less than 4, that's a true statement. So that means we shade this interval. Okay. If you had a true-false test and you were taking it and someone told you all the answers alternate and you knew the first answer was true, could y'all guess the rest of them? What would you guess this one is? False? Just based on what the word alternate means. And what about this one over here? True? Well, there's a way you can look at these and determine if they alternate. And I'll tell y'all that in a moment. But for right now, let me see. Let's go ahead and plug in these other numbers and see, is it really false here and true here? Okay? So plugging a negative 3 into the original problem, this thing that has the less than or equal to. 3 times negative 3 is negative 9. Negative 3 plus 2, is that a negative 1? Did I guess right? Is this going to turn out to be a false statement? What's negative 9 divided by negative 1? 9? Mm-hmm. So true or false? False. Okay. And I've guessed false, and I've guessed correctly. Now let's see if we plug a 0 in. I'm guessing that it's going to be true. Let's see, plug in a 0. 3 times 0 is 0. 0 plus 2 is 2. 0 divided by 2 is 0. Is that true? Yeah? Mm-hmm. Okay. So we found those numbers called cut points that have the open or closed circle. We plotted them on the number line. We've tested the intervals to shade some. Now our last step is what we were reviewing on Thursday. No, not on Thursday, it was Monday. In the class on Monday was when we did this. I keep thinking today's a Tuesday, I think. But express the shaded intervals using interval notation. How would the interval notation look? Call it out like y'all were calling it out the other day. We would go parentheses, negative infinity, comma, negative 8, square bracket. Remember, closed circles have square brackets. Open circles and infinities have parentheses. Then we have that U shape that's red union, which means it's all on the same number line. Oh, oops, let me lift that up. Sorry about that. There. You put a union there, which just means it's two regions on the same number line. And now call it out. How am I going to write this blue region in interval notation? Parentheses or bracket? Parentheses, negative 2, comma, infinity. Let me punch that in so y'all can be confident that I'm doing these correctly. See, parentheses, negative infinity, comma, negative 8, bracket. I'll just use the square bracket that's on the keyboard. For our purposes this semester, we'll use union. This little symbol here is set intersection. If you took remember any union, intersection, set theory, then great. If not, for our purposes, just remember you only use the U, not the upside down U. What's the other one? Parentheses, negative 2, comma, infinity, close parentheses. I'm going to reluctantly say, are there any questions there? It takes a while to get accustomed to these steps, but if you look at each little piece, it's not anything we haven't already done. Okay? Solve the equation. Equation has an equal sign. Find where the fraction is undefined. We were doing that in lesson 6. Okay, draw a number line and label and test your ordered pair. Oh, let's see. Get it back at this. Oops. Each little piece. Okay, solve the equation. We've done that this semester, solving an equation. Find where the fraction's undefined. That's what we were doing a week ago today. Draw a number line, label, and then test. In general, here's how you can look at one of these and tell if it alternates. This is the only one that I'll be using, that I'll actually go through and test every interval. In general, if there's no factoring involved anywhere in the problem, then it's going to alternate. Like over here, on this one, there was no time that we had to factor. Remember, draw the parentheses and stuff. If you have to factor, only if there's repeated factors do you have to get concerned that maybe it isn't going to alternate and you need to just check every interval. And what do I mean by repeated factors? Well, if when you're factoring, you draw your two parentheses, if you get the same thing in both sets of parentheses, it might not alternate. So then you have to do what I did here and check every one of them. Okay? Now, in this assignment, in this course, there's not going to be any with the repeated factors. So for y'all's purposes, you can check one of them. I won't be checking every one like this. What I'll do is after I've drawn the number line, I'll generally ask myself, where is 0? 0 is usually the easiest number to test. And that's the one I'll usually test. But you can test any number as long as it's not a cut point. The two numbers you couldn't use as test points are -8 and -2. Oh, by the way, I started writing out step 1, step 2, step 3. Right here is step 4. Writing the interval notation, that's step 5. Okay? I thought this was a good first one because it shows all of the steps. Let me come back over here. Let's go back to problem 3 now. problem number 3 doesn't have a fraction in it. If there's no fraction, then you're not going to be doing step 2. Okay? If there's no fractions, then you just skip this second step. Let's go ahead and make a note of that here on this little recipe. Skip if there are no fractions. I think most of the there's more problems in the assignment that don't have any fractions, and you'll skip this denominator cut points than are. Okay? So looking back at problem number 3, I can tell right off that I'm not going to have any denominator cut points. Why? There's no fractions. Okay? So let me write down number 3, and then we'll get started. Are y'all caught up? X times x minus 1 is less than or equal to 20. Down. X times x minus 1 is less than or equal to 20. By the way, how were the instructions worded? It says solve the quadratic inequality. And inequality means there's a less than or greater than in it. Quadratic, what does that mean? Do y'all remember? It means there's an x squared in the problem. At first glance, you might say, hey, I don't see an x squared. You will in a moment, okay? So, and then write the solution set in interval notation. Notice it does not say use cut points. Okay? Oops. So, starting with step 1, finding the solution cut points. Replace the inequality with symbol with an equal sign and solve for x. Okay. So I'm going to have x times x minus 1 equals 20. And I wanted to do this example just because I don't recall having solved an equation like this in this format this semester, at least as an example. You're given the hint that it's quadratic, that you should have an x squared, and here's how you get that x squared. Distributing the x, you'd have x squared minus x equals 20. So, there's an x squared. We have 2 primary methods for solving quadratic equations. The quadratic formula or factoring. Regardless of which method you want to use, you've got to have what number on one side. Instead of this 20, what number should be there? A 0. So what am I going to do to both sides in order to get this 20, or to get rid of this 20 and get a 0? Subtract 20. If I subtract 20, I'll just put the little arrow, meaning move it over and change the sign. We have x squared minus x minus 20 equals 0. And if there were some really large numbers here, you might say, okay, I'm going to go straight to the quadratic formula. But there's not that many. Heck, I guess if you look, there's only one number, 20. What are the numbers that multiply together to give 20? There's 1 times 20, 2 times 10. Is there another pair you can think of? 4 and 5? When you're factoring, that's when you're drawing the 2 sets of parentheses and fill it in. What do I put in there so I can FOIL it out and get x squared minus x minus 20? What goes here and here? X, yeah. X times x. The second sign is minus. So what kind of numbers multiply together to give a negative? 2 positives, 2 negatives, or one of each? One of each. So second sign is minus. Use 1 plus and 1 minus. Notice how I'll wait to fill it in. And do y'all have a feeling which pair is going to work? 1 times 20, 2 times 10, or 4 times 5? 4 times 5, that's right. Now, how should I arrange that plus and minus in order to get a negative x? If I look at the outer and inner on FOIL, I know for first I'm getting x squared, and last the 4 times 5 is giving me the 20. But how do I need, in order to get a negative x, that would be a negative 1x, is that right there? A negative 5x and a positive 4x, is that what I heard? And what do I put in front of the 4? Plus and a minus. If you want to FOIL that out in your head, are you getting x squared minus x minus 20? You'd have x squared. Then these marks here and here are the outer and inner. Negative 5x plus 4x, that's a negative 1x. Then positive 4 times negative 5, negative 20. So, have we factored it correctly? Yes. Set each factor to 0 and isolate the x. So, x plus 4 is 0. So we have x equals negative 4. And what's our other cut point? 5? Now, oh gosh, I sort of smeared, my ink smeared here. I guess I did that. That's a less than or equal to. So what are we going to put? Open or closed circles? Closed, okay. If there's an equal sign on it, use closed. If there isn't, use open. If there's no denominator, skip step 2. And there's certainly no denominators in the original problem. So we'll draw our number line. Negative infinity, positive infinity. Oh, good, there's no 8s on the number line. A negative 4 and a positive 5. Make sure you put these numbers in numerical order. The negative 4 is closer to the negative infinity. The positive 5 is the one closer to the positive infinity. If you put those numbers out of order, if you put the 5 here and the negative 4 there, you're just going to have a mess. Okay? Now, on this particular problem, we did some factoring. So, did we have any repeated factors? Did we get the same thing in both sets of parentheses? No, we got an x plus 4 and an x minus 5. So that means it's going to alternate. So I'm only going to test one interval, and here's how I'll go about it. Realize you can choose any number to test other than negative 4 and positive 5. I'm going to choose 0, but where is 0? Which interval am I testing? Is 0 between two negatives? Between a negative and a positive? Or between two positives? Yeah. It's at the end of class, you walk out and a student says, oh wow, you just got out of Mr. Precella's algebra class. What did you learn today? You can say, I can locate 0 on the real number line. Okay, a couple of people laugh. Yesterday, no one laughed at all. And I was meaning that as a joke, you know. You can locate 0. I think you could probably have located 0 on the number line before you ever walked in here. But that's a good thing to say. Okay, so I'm going to test 0 by plugging it in here. Oops. Right up here. Yesterday, my brother did so much of the writing, and I kept telling him, write smaller, write smaller. And I'm having that same problem here. Plugging a 0 in for x. We'd have a 0. And what about in the parentheses? 0 minus 1. That's a negative 1. What we're trying to do is decide, is this true or false? If it's true, we shade it. If it's false, we cross it out. 0 times negative 1 is 0. So it's sure not equal to 20, but is it less than 20? Yeah. So I'm going to say true here. So that means shade this interval. Are we going to shade any of the other intervals? No. Cross them out. If the middle one is true and they alternate, then the other ones have to be false. Now, if you just want to test and make sure, choose a number between negative 4 and a negative infinity, like negative 5, negative 6, negative 7. If you want to test that one and make sure you get a false one, or choose a number between 5 and infinity, like 6, 7, 8, 9, 10, fine. I'm not going to. What I've discovered over the years is the more you test, the more likely it is you're going to make a mistake. Okay? Back in the olden days, I used to say, like the books will say, test every interval. Okay? And then I'll wind up with people getting true, true, false. That hardly ever, ever, ever happens. So choose an interval that's easy to test, and then put all your eggs in that basket that you didn't mess up. 0 is less than 20. So how do we write this answer in interval notation? Am I going to use a union symbol? No. It's just going to be a bracket, negative 4, comma, 5, bracket. When I was in college, I saved all of my math notes. I didn't save my history and English notes, but I saved all my math notes. Just threw them away at the end of 2019 in preparation to move from the old building into the new building. And I still had the notes of my brother and I both had the same teacher, and her method for solving these was think about it. That's how we solve. And I have notes showing this, where you just sort of sat there and thought about it until miraculously you got negative infinity to negative 8, union, negative 2 to infinity. Or coming over here, you just thought about it until you came up with this answer. Let me tell you, if there's a math teacher saying just think about it, that means they don't know how to do it. Okay? It was just a nightmare the first time I ever saw these steps. First of all, I felt stupid. Back then, there wasn't my math lab, but we had a paper book. I could have just looked through the paper book to see how are they saying to do it. But I trusted, well, they're just going to tell us to think about it. Oh, wow. A sequence of steps is so much better than just think about it. Okay? You're going to make some fancy dessert. Do you want a recipe, or do you just want to think about it and make that dessert? I would prefer the recipe to follow. That's why I call this a recipe. You follow it step by step by step. It'll solve any type of inequality out there. Remember years ago, a tutor telling me, oh wow, that cut point method of yours is really amazing. It will solve any type of inequality. I don't know why it works, but it works. And I thought, oh, I hope you do know why it works. what's the basis of this? Like on this problem, we're trying to figure out when something is less than or equal to 20. Find where it equals 20, and everywhere else it's either going to be bigger than 20 or smaller than 20. That's the logic. Find where it equals 20. Everywhere else it's either bigger or smaller. On a fraction, find where it equals 4, but you also have to take into consideration that the fraction could be undefined. But everywhere else it's either bigger than 4 or less than 4. Like right here, it was less than 4. Here it was bigger than 4. Here it was less than 4. It's a very logical process. And this cut point method will solve anything that has a less than or greater than. Let's do, any questions? Y'all caught up with me? Oh, what's happening? Okay, good. Number 6. Hey, right now you can tell. Will there be any denominator cut points? What do you think? Yes. Why? Well, there's a fraction. So problem number 6. Oh, it's a z. Got to be careful because I don't want that to wind up looking like a 2. Z over z minus 11 is greater than or equal to 2z. Z over z minus 11 is greater than or equal to 2z. Well, let me lower it a little. Y'all already getting familiar with it enough not to have to read every single word here? You start off finding the solution cut point by putting an equal sign. So solution cut point, replace that less or greater than or equal to with an equals. And we're going to solve this. If I put over 1, does that give you a hint of what we're going to do here? How am I going to solve this for z? Cross multiply. Whenever your fraction equals fraction, I think it's easiest to cross multiply. So let's see, what would we have? We'd have, oh wow. Of course there's a 2 in front of a z. Hopefully you can tell my 2 from a z. 2z times z is 2z squared. And a minus, 11 times 2z, is that going to be a 22z? You'll see I'm cross multiplying. I'm having to multiply the 2z times the z and the negative 11. So we have 2z squared minus 22z equals just a 1z or z. Is this a quadratic equation? It's an equation because there's an equal sign. Quadratic means square. So it's a quadratic equation. And I wanted to do this one because I'm not sure, I don't recall doing an example like this where we're going to have to factor something that doesn't have a constant. Everything we've factored so far, there's been that constant, that number that doesn't have a variable. Don't panic. This one over here is the easy type to factor. So remember how to do that? You got to get a 0 on one side by subtracting z. So I'm going to say minus 1z. The way this is different from the other factoring that we've done so far this semester is there's not that constant here. Negative 22 minus 1 negative 23. So how do we factor something if there's not that constant? Well, do y'all remember the phrase factor out a variable? You're going to do reverse. Instead of reverse FOIL, it's the reverse distribute. Formally, we say we're factoring a z from each term. If I took one z out of each one of these, what would be in the parentheses? We'd have, it's called factoring out a variable. So we'd have a 2z here, and minus 23. See, you could check it by distributing the z. If I distribute the z, am I getting 2z squared? Oh, yeah. Then a minus 23z? Yeah. That's some of the very, very, very first type of factoring you would have ever done in your first algebra class. Okay? What we've done up until now has been that reverse FOIL stuff. That's the more involved factoring. How does this one differ from this one? Well, on all the other factoring we've done, we have that constant. We have the 3 terms and a number. Here we just have the 2 variable terms. We don't have that 3rd term. Now set each factor to 0, and here's the thing that's tricky. You've got to even set the z equal to 0. And the z is already isolated. Take the black stuff, the 2z minus 23, set it to 0, and now isolate the z. What would I need to do? How would I isolate this z? Add 23, So I'm moving that 23 over. So we have 2z equals positive 23. And then what? Divide by 2. So 23 over 2. Oh, what would that be? About 11.5? But I'm not going to write 11.5 because Pearson, they don't like decimal numbers. Okay? But you might think of it as 11.5 when you're punching in, or when you're graphing it on the number line, just to locate where it is. Now, those were solution cut points. So what symbol are we going to use? Open or closed? Closed, because there's an equal sign. So let me make a note. There's an equal sign on it, so we're going to use a closed circle for both of them. So far we've found 2 cut points, 0 and 23 over 2. Now, let's find the denominator cut point. That's the usual, if there's a denominator cut point, that's usually the thing that's easier to find. What do? You just say denominator can't be 0. So z minus 11 can't be 0. So isolate that z. What would we have? Z can't be 11. Open or close circle. Always open on the denominator cut points. We'll draw our number line now. Okay, there's 3 cut points. There's the 0, 23 over 2, and 11. Let's make sure we get them in numerical order. Which one is closest to negative infinity? The 0. Now that leaves 23 over 2 and 11. 11 would go next because 23 over 2, 23 divided by 2 is 11.5. Is your hand going up or no?
No,
Oh, okay, okay. That's fine. I'd be yawning too if I was sitting out there, trust me. And now after all of that, I forgot. Which one did you say goes next? 11. And then the 11 over 11.2, 11.5. But I'm going to write it as 23 over 2. Pearson doesn't want you to use decimals unless we're talking about dollars and cents. Okay? So, close circle on the 0 and the 23 over 2. Oh, wow, this would be just such a good problem if all we were doing was just thinking about it. I tell you, think about it. That's a lot harder. Mm-hmm. And we did the teacher evaluations at the end of the semester. And it haunted me for years because it asked about, was there something that the teacher did that you didn't like or something that, and what did both my brother and I write? Think about it. And I thought, oh, wow, I hope I didn't make an enemy for life, but... okay, so now we had some factoring in here, right? We had to factor that z out, but there were no repeated factors. We didn't get two sets of parentheses with the same thing in it. In fact, we just had one set of parentheses. So it's going to alternate, but I can't use 0 as the test point. Why? Because it's a cut point. So use any number other than 0, 11, and 23 over 2. I think I'm going to use 1. How about using 1 as a cut point? As a test point. But you've got to figure out which interval are you testing. Where on the number line would 0 be? Between negative infinity and 0, or between 0 and 11, or between 11 and 11 and a half, or between 11 and a half and infinity. You see, you can also tell your friend, not only can I locate 0 on the number line, I can also locate 1. Where would 1 be? Right there beside to the right of 0, it's in this interval. Why does it matter where it is? Well, that's the interval I'm testing. I've got to know which interval I'm testing because this is the interval I'm either going to cross out or shade. So I'm testing 1. Plug it in up here. On the top, we'd have a 1. What would we have on the bottom? 1 minus 11 is negative 10. Is greater than or equal 2 times 1. Would that be a 2 over here on the right-hand side? So this fraction right here, 1 over negative 10, that's a negative number. So this number over here is positive. Is a negative number ever bigger than a positive number? No. What do y'all think this interval is? True or false? It's false. So that's how you know which interval to cross out. You've got to locate which interval are you testing. So we cross this one out. And can you do the rest of them? What's this one going to be? True. And right here, the third interval, true or false? True. If you know what alternate means, if this one's false, that one's got to be true. False, true, false. So, let me write it down. I'll write the answer right here. Put parentheses by an infinity symbol. So parentheses, negative infinity, comma, 0, bracket. Notice when you're writing interval notation, you're going from left to right. Always left to right. Don't write 0, comma, negative infinity. It'll count it wrong. The left-hand endpoint, the right-hand endpoint. Union. parentheses 11, comma, 23 over 2, bracket. So if you have a friend in another algebra class and they're asking you for help, you just tell them, think about it, okay? Just think about it. Let me see. Parentheses, negative, infinity. Oh wait, what did I do? I had a 9 instead of the parentheses. Negative, infinity, comma, 0, bracket, union, parentheses, 11, comma, 23 over 2. Be careful. I want to illustrate a mistake. If I put that bracket right there, it shouldn't be down there in the bottom of the fraction, should it? It's going to say, okay, wrong. And then they sort of talk you through here. But they say first find the values that make the denominator 0. So on this little hint here, they're finding the denominator cut points first, and then the solution cut points. Okay? But that's not what we did wrong. What was wrong on this one? I need to come back and remove that bracket. It's not supposed to go in the bottom of the fraction. It should be like that. I'll hit a right arrow, get there, and the bracket. Any questions there? This cut point method will solve anything that has a less than or greater than if it says to solve it. Even if there's absolute value bars. Okay? So before we do starting with problem 8, there's going to be absolute value bars in it. Now I want to make sure y'all remember that stuff that we did the last time. To solve an absolute value equation, where's that stuff we did the last time? You would say equal positive, equal negative, but you had to always isolate the absolute value bars first. If those absolute value bars weren't by themselves, you would have to move whatever is with it to get them by themselves. So this is the stuff we were doing on Monday. Okay? We're going to start doing that now. That's what sometimes people think makes math hard. It just keeps building. What we did Monday, you're going to do today. It's just one step. Okay? So let me write down problem number 8. Hey, will there be any denominator cut points on this one? No. So this is number 8. Absolute value of 3 minus 2x is greater than 10. So this is an inequality. It has a less than, well, it has a greater than. If it has a less than or greater than, that's when you use this sequence of steps. We start off by solving the equation. Notice the absolute value bars are already isolated. The next one we do, they won't be. We'll have to do a little something with that. But they're already isolated. So what sort of numbers have absolute value equal to 10? What are the only 2 numbers that could be in here to give us 10? I'll get you started. Positive 10 and negative 10. This is when you do that plus minus stuff. Take what's inside, set it equal to positive 10, set it equal to negative 10, And that's how you're going to get your solution cut points. So how would I isolate the x? What would I need to do? Yep, minus the 3. So 10 minus 3 is 7. And then divide both sides by... So our first cut point is negative. I like to write it with the negative out in front rather than leaving it in the bottom of the fraction. Negative 7 over 2, which is which is exactly negative 3.5. What about over here? We would do those same steps. Subtract 3. So is that going to be a negative 13? Divide both sides by negative 2, and what are we going to get? Positive. Even though they're both fractions, it's easy to locate on the number line because one's negative and one's positive, right? Oh, before I draw the number line, these were solution cut points, so open or close circles. Okay, because there's not an equal sign, it's going to be an open circle. Draw a number line. The negative number is always going to be closer to negative infinity than the positive. Negative numbers are to the left, positive to the right. Zero is not the cut point, so that's the number I'm going to use to test. But which interval am I using? If I'm going to use 0, where does 0 lie? Between two negatives? Between a negative and a positive? Or between two positives? Yeah, 0 is always between a negative and a positive. So plugging a 0 in for x. Okay, putting a 0 here. 2 times 0 is 0. 3 minus 0 is 3. And then the absolute value of 3 is just 3. So are we getting a true statement or a false statement? False. So that means cross out, shade this one. What about the third one? Shade it or cross it out? Yeah. So we'll write it out in interval notation. Parentheses, negative infinity, comma, negative 7 over 2, close parentheses. Union means that this next one is on the same number line. 13 over 2, comma, infinity. So let me type that one in. Parentheses, negative infinity, comma, negative 7 over 2. I'll hit the right arrow to get out of that denominator. Parentheses, union. That's the U, not the upside down U. Parentheses, 13 over 2. Don't put the comma in the bottom of the fraction. Don't do that. Okay? I'll hit right arrow, then put the comma, infinity. Sometimes it might be hard when it's blowing up the symbol, the brackets and parentheses, to tell is that a parenthesis or a bracket. But look, if I put a bracket there, can you tell the difference? Bracket, parentheses. The parentheses are a little more curved than the square bracket. So, where's that from? There. Any questions? Notice how we're just putting stuff we've already done, we're just sort of adding another step to it, okay? Let's see. Okay, number 9 is a good one. Let me write this one down. How is 9 different from the one we just did? Well, absolute value of 3x plus 5, then a minus 10. Hopefully, that's not a 13x plus 51. Those are absolute value bars. I make them look darker, but they seem to make them lighter than numbers. Okay. There's something we have to do first on this one before we do anything else, and it goes back to something we said on Monday. Notice how you've got to isolate those absolute value bars. Always, always, always isolate the absolute value on one side of the equation before solving. So what am I going to need to do on here? There's only one correct first step, and it's what? Has to do with this 10. Add 10? So you can either draw that or go like plus 10, plus 10. So here it is. Absolute value of 3x plus 5 is less than what? Negative 2 plus 10. What number am I going to have right here? 8. The most basic problem-solving strategy. If you know how to do one type of problem, and you have a new one, make it look like the other one. I claim this one now looks like number 8. There's an absolute value bar, a number. Well, that number 8 had a greater than, number 9 had a less than. That's not going to affect or change how you go about it. What am I going to do now to find the solution cut points? Notice there's not going to be any denominator cut points. There's no fraction. So how do we solve an absolute value equation? What did we do the last time? We go 3x plus 5 equals 8. And then we also go 3x plus 5 equals, this is where you're going. Equals positive, equals negative. Let's see, how would I solve this for x? You would move that 5 over, and we have 3x. Is that going to be equals 3? And then divide both sides by 3 to get x equals 1. What about the other cut point? Subtract the 5. Are y'all getting sleepy and tired? Only one more after this, so try to stay awake and we'll get it done. So subtract the 5, and then, So is that a negative? We'll just write it 13 over 3. Oh, and I almost forgot to decide between open and closed circles. What should we use? Open, because there's not an equal sign, so it's going to be an open circle. So let me draw my number line. Negative infinity, positive infinity. Let's see. The negative, should it go first or second? Yeah, it's going to go right here. And negative 13 over 3 is the one that should be closer to the negative infinity. The positive 1 closer to the positive infinity. And open circles. You want me to guess what number I'm going to test? 0? Mm-hmm. So 0 goes where? Is it between two negatives? A negative and a positive? Or between two positives? Yes, this is the interval I'm testing. So when I test this, I'm going to plug it into this one here. So I'll move the 10 over. Okay. After you've isolated the absolute value bars, you don't use this for anything else. Okay? I'm just faintly doing that. This is the one you use. And it'll be the easier one to use to test also. So let's plug a 0 in for x. Putting a 0 right here. 3 times 0 is 0. Plus 5 is 5. Oh, that's not 151. It's the absolute value of 5, which is 5. So true or false? 5 is less than 8. True. So shade that middle interval, and what am I going to do to the other two? So it's going to go parentheses. Negative 13 over 3, comma 1, close parentheses. Remember, you're putting parentheses at the open circles. Okay. We're going to start graphing the next time, and if you remember graphing, you might think, well, that looks like those ordered pairs, x, y. Yeah, it does, but not an ordered pair. Here, we're using it to represent numbers on a number line. They always give you that solution, that option about no solution. I'll give you a hint. If you choose that one, you're messing up somewhere, okay? There's going to be a solution for all of these. Negative 13 over 3, right arrow, comma 1, close parentheses. A word of warning: if you're if you're a view and example person, with the view and example, they have some special rules that they use for absolute value bar problems, but I don't use those rules. I use the cut point method. So I memorize new rules when the cut point method will do anything that has a less than or greater than. But problem number 11 and 12 are both the same type of problem. We'll do problem 12. That'll be our last example. Once you get to number 13, the last three problems, I just start at this point of the semester putting old stuff, reviewing stuff, like number 13. Do y'all remember this from, what was it, day 2? How do I simplify square root of negative 64? Yeah, so I'm going to put in what number? 8, and then I, those imaginary numbers we did during the first week of the semester. So towards the end of the assignments, I don't know why that last assignment, it only had 7 problems. I guess I was just too lazy to, I thought maybe y'all needed a break. Okay, but let's go back to problem 12. 11 and 12 are the exact same type of problem, and I highly recommend that you don't use the view and example on this one. I can't turn off the view and example option for 1 or 2 problems without turning it off for everything. But every semester on this particular assignment, I think, should I do it? Should I just remove the view and example button? Because I don't want you to be doing the absolute value ones, doing what they do with the view and example. Okay? I want you to do cut points. Why am I saying that? Not to be difficult, but the cut point method is the easier method. Let me write this problem down. We'll work it out with the cut point method. And granted, it's going to be a little bit more involved than the one we just finished doing. But if you just look at what the heck they're doing on view an example. I remember one semester, a sweet little student asked me, what are we supposed to do if you say don't look at view an example? How do we know how to do the problem? And I was like, well, I was kind of sort of thinking maybe you would do what I did in class or watch the videos. I have quite a few videos, those media assignment there at the beginning. Some of these I know are, let's see, is this the one? Let's see, maybe it's this one. But there's one of the videos where I'm working out that's the full class lecture. So, class lecture, part 5, example like problem 11. It's actually 11 and 12. Problem 11 and problem 12 are both what we call quadratic absolute value inequality. So if you want to impress someone with terminology and you want to tell them what you did today, you can say, we solved a quadratic absolute value, quadratic means x squared, absolute value inequality using what method? What's the name of the method we're using? C and P are the first letters of the two words. Cut points. You're going to solve a quadratic absolute value inequality using cut points. That's the best way to solve it. Well, do I need to isolate the absolute value bars first, or are they already done? They're already isolated. So we go straight to solving it with an equals. We don't have any denominator cut points because there's no fractions. So we're going to go, what are the two numbers that have to be in here? A positive 3 and negative 3. So take what's inside there and go equal positive, equal negative. So go equal positive 3, equal negative 3. And this is now a quadratic equation. So get a 0 and factor. All right, let's get a 0 on one side. To get a 0, would y'all move the 3 over? Is this something we've done already this semester? Get a 0. Let's see, negative 9 minus 3. Is that going to be a minus 12? Now, this is one of those factoring where you have to draw the two sets of parentheses. Let's see, there's that constant. What numbers multiply together to give a 12? Well, 1 times 12, 2 times 6, 3 times 4. Y'all have a feeling of which pair is going to work out to give us this middle term? Yeah, 3 and 4. You go x and x. Second sign is minus, so that means you have 1 plus and 1 minus. So I'll put a 3 and 4. Help me figure out how to arrange the plus and the minus so that I get a positive x. Minus on the 3 and plus on the 4. I agree with that. So we have, and now I'm just checking to make sure. I've already said I agree with it, but still, for illustration purposes. Negative 3x and a plus 4x. Is that giving me a plus x? Yeah. So what do I need to do now to get those cut points? I take each factor, set it to 0. There's going to be a lot of cut points here. And what would y'all do? Would y'all add the 3 to both sides? Is it now hitting you in the face and bouncing off? And subtract the 4? So we have x equals 3. And what's that other cut point? Is that going to be a negative 4? Now let's come over here. Notice it's basically the same thing I was doing right here. Equal positive, equal negative. Except over here we had linear. There was no exponent. Over here we have those quadratic. So you're going to have to get a 0 and factor. So let's see. I'll get the 0 by moving the 3 over. So we have x squared plus x. Negative 9 plus 3, what am I about to write here? Oh, you said negative 6, and look what I did. Oh, gosh. Negative 6 equals 6. Ignore that big black blob there. Well, that's a negative, and 6. Well, let's see, how do we factor it? Well, numbers that multiply together to give 6, so 1 times 6 and 2 times 3. Can y'all get this one factored? X and X. Which pair do you think is going to work? The 1 and 6 or the 2 and 3? 2 and 3? And it's a negative 6, so we need a positive times a negative to get a negative. How should I arrange it? To get a positive 1x, let's see. We'd have 3x, 2x. We want a positive x, that's a positive 1x, so how would y'all arrange that plus and minus? Would there be the bigger number needs to be positive. Would it go like this? Foil that out and see. Is that right? Okay. Almost done. I'll set each one of these factors to 0. And we get x equals positive 2 and x equals negative 3. So it looks like we have 4 of those solution cut points. With solution cut points, open or closed circles, depend on the symbol, we're going to have open. Okay? Because there's a greater than right there. Let me just make a note. Oops, open. So I'll draw the number line. So this was a little bit more work because they're both quadratic, but it's not that bad, is it? Got to arrange the 4 numbers on the number line. And make sure you put those numbers in numerical order. Which one of these 4 cut points is going to be closest to negative infinity? Negative 4? And then call them out in order. What am I going to put here? 2 and 3. Well, we're going to test one interval. I'm going to use 0. But here, notice there's how many intervals? 1, 2, 3, 4, 5. Which of these intervals contains 0? That's the one I'm going to test. Negative 3 to 2. Good. So we're testing 0. Now this is going to be tricky. Watch out. If I put a 0 in for these blue x's, 0 squared is 0. So we have 0 plus 0, that's 0, minus 9. 0 minus 9 is a negative 9. But wait, don't decide true or false yet. Actually take the absolute value of negative 9. What's the absolute value of negative 9? It's 9. It might have been lost on you that something that I was writing as I was doing these. If I had absolute value of 5, and then I just wrote it 5. You've got to take that absolute value before you decide on true and false. Now we have 9 is greater than 3, true or false? True. It's very, very tempting once you see this negative 9 here to say false. But you've got to take the absolute value first. You might say, well, you didn't do that over here. Yeah, I did. But the absolute value of positive 5 is just positive 5. Right here, the absolute value of 3, notice how I wrote it. It's just 3. Okay? You've got to take that absolute value first. So that interval's true. So can you go through alternating all the rest of them? False, true, false, true. And then we got to write all these intervals. Parentheses. You can impress people with this problem. What do I mean by that? There's a lot of people. Now, you might find tutors that don't know how to do this problem. Why? Well, they might be trying to follow the view and example on here. Let me put this answer in to make sure it's correct so that you're more confident. Back in the olden days, we used to work problems from the paper book. And the paper book would have the answers in the back. Now remember, I'd work a problem and then everyone turn into the back of the book to look and see if it was correct. And I was like, oh wow, they have so much confidence in me. But now you don't have to have confidence in me. Pearson will tell you if I got it wrong. Oh, and now we're not finished with this question. It just dawned on me. Look at this next part. They want you to choose the correct number line. Well, our number line, my number line, I use open and closed circles. Okay? Rather than parentheses. But on their little number lines, what they put are the brackets and the parentheses. Which one of these, A, B, C, or D? B? Yeah. A word of warning. Here's the view and example. There's 20 parts remaining. And what they're doing here, notice, with the cut point method, how many less thans and greater thans do I write? Just, right, it's there. But during all of this, are there any less thans or greater thans? Not until you test. Here, they're trying to use these little rules that they've given you about absolute values that just sort of fall apart. My brother laughs and says he's convinced that they're just writing a whole lot of stuff down until they can pop out the answer. Okay? So right now, at this point, they're right here. Okay? And just continue on. And then, how many number lines do you need to draw? Notice, I didn't draw a number line at this point, once you find the first two cut points, but they did. They draw a number line and test a number line there. Totally unnecessary. I'm not going to say wrong. I'm just going to say unnecessary. And then finally they're at the point, they're testing now. They're now at this part, doing this. And they're going to go on. It's just absolutely crazy. I once read through all of their logic on how they're doing this. Let me tell you, it falls apart if there were a less than here. You see, my method, the cut point method, and I do call it my method, okay? Dr. Howard Rolfe called it cut point method in a book at Baylor when I was teaching there, and I adopted the name then. But, my method, you don't draw all these different number lines. One number line at the end, test an interval. With their method, they go through and do a little hocus pocus until finally they come up with the right answer. And after they do the hocus pocus, they use the right answer to draw the number line. Oh, wow. Maybe next year I'm going to turn off view an example for every one of these. But problem 11 is exactly like it, and I can tell now y'all are sick of this stuff. It was a long one. We'll follow up a long one on, let's see, today's Wednesday. Monday, it'll be a shorter one, okay? So whenever we have a really intense assignment, we'll try to follow it up with one that isn't quite so involved. So, are there any questions on any of this? How do you know when to use this cut point method? Notice at no time do they ever say in the instructions. Again, I'm telling you to study the instructions. Well, if it says solve an inequality, even if it didn't say that, if it just has a less than or greater than, that's when you follow this. Okay? So, I'm going to